Hello friends, very good evening. I extend a hearty welcome to my YouTube channel. Myself, Dr. M.H. Annaiah. Friends, in today's video, we are going to work out a problem on the projection of a pentagonal pyramid, which is going to rest on one of its triangular faces on HP, such that one of the base edge containing the triangular face is parallel to VP and at a distance of 10 millimeter from it. Draw its projections. Friends, generally the pentagonal pyramid, hexagonal pyramid are the choice of questions of the examiners. So generally if it is a problem on a pyramid, very often they ask the question on pentagonal pyramid. So friends, you have to go through the problem twice and just analyze what is the data given. And in today's video, let us see what is the question given. A pentagonal pyramid of side 30 mm and height 60 mm rests on one of its triangular faces. So this is a very important point. Friends, whenever a pyramid rests on one of its triangular faces on HP, or the triangular face is inclined to HP, or a prism resting on one of the shorter edges, or it is resting on a rectangular surface. For these two cases of pyramids and prisms, place the object on HP such that one of the shorter edges of the pyramid or the prism is perpendicular to VP. Obtain its top and front view. Friends, here we are given the question on pentagonal pyramid. So I place the pyramid on HP with one of the sides. Say this is AB, we will call A, B, C, D, E, perpendicular to VP, and you will obtain what are called its front view with a height of 60 millimeter. That is given in the question that the pyramid has got a height of 60 mm. Let us mark all these points, friends. This is A dash, B dash, this is C dash, E dash, this is C dash, E dash, this is O1 dash, this is D dash. This is how the pyramid looks in the top and front views. Friends, in the top view, OA, OB, OC, OD and OE represent the five slant edges of the pentagonal pyramid, and they are represented by O dash D dash, O dash A dash, O dash B dash, O dash C dash and O dash E dash. And friends, if you observe the front view, you will see in this triangle we have this last line, and this line has got OAB, that is O dash A dash B dash, and this line represents a triangular face because there are 3 points OAB, whereas on the other end O dash D dash represents one of the slant edges. We are not interested in that. Now this is one of the triangular faces. There will be 3 such faces. It is one such. So he says it has to rest on HP, on one of its triangular faces. So friends, this is the triangular face we have got here, and we have to make it to rest on HP. So what should we do? We are going to redraw this figure such that that triangular face O dash A dash B dash is here, or D dash goes up. This is our A dash B dash, this is O dash, and we have the axis, and also we have the other 2 slant edges, namely C dash E dash. Friends, you can observe here the solid is resting on O dash A dash B dash, that is one of the triangular face. Triangular face is on HP, is on HP. And friends, Let us see how does it appear in the top view. Friends, in many of my previous videos, I have given the clue that whenever any pyramid or any cone rests on HP on either the generator in case of the cone or slanted in case of the pyramids or triangular face in case of the pyramids, the complete base, for example here, this last line represents the base of the solid that is completely visible to the observer in the top view. So friends, we will take these points one by one and obtain the complete base. So I will write a vertical line from A, horizontal line from here. This is point A. Similarly, you get point B. Likewise, you get point C and E on this. So this is our E. Same line you have got this C here, C and E. Finally, we are going to get the point D. So friends, this is how we obtain the complete base of the solid. So say up to here. So this is how we get the 5 points. I told you the complete base is visible. So all these are to be joined by visible lines. So we will join them by visible lines. And then this will give you, this is point B and this point is going to be a point on the C. So we are going to have this A, B, C. This is how we get the complete base of the pyramid. That's going to be a pentagon. If it's a hexagon, you get a distorted hexagon. Friends, now we can see this is A, B, C, D and E. Friends, you have to observe a very important concept here. Generally, when the object is resting on edge, students do commit some mistake of marking. So instead of marking EB here, they may go wrong here. You have to be very, very careful. Let's obtain this point O the vertex and join that vertex to all the corners. First of all, let us join them, this O to E, then O to C, O to D, and friends, next you have to see that when you are joining the vertex to A, what happens? It is intersecting ED. So now we should be very careful whether to join that by a dotted line or by a full line. Friends, remember, when any of the pyramids or the prisms or the cubes, whenever two lines intersect, if one of them is a full line, the other has to be a dotted line or invisible line. So friends, I am going to join. When I join O to A, it is intersecting CD. So this has to be necessarily a dotted line. Similarly, friends, for the case of B also, you have a dotted line. Friends, this is how the solid looks in the top view when it is resting on triangular face on HP. On triangular face is on HP. But what does it say in the question? It is resting on triangular face on HP with a shorter edge of that face is parallel to VP. Friends, in the base, it is resting on OAB. In the top view, OAB is the triangular face. There he says the shorter edge is AB. That AB should be parallel to VP. So what is to be done? We have to redraw this figure such that this line AB becomes horizontal and it should be at a distance of 10 mm. So we have to mark a line here at a distance of 10 mm because this 10 mm can be seen only in the top view. It is a distance of 10 mm. So on that you have to get this AB. So I will mark A and B here. This is AB. You can say this is A. This is B. And then you can locate this D at this distance exactly in the center. You can have that D somewhere here, the point D. Then to the left of D is E. So somewhere here you get, friends. You have to just transfer all those points one by one to get the complete projection. So friends, you got all the 5 points, and all the 5 points or the corners are completely visible, and hence I show them by full lines. This is how I obtain this particular base, and then we have to obtain the vertex along this line at the given distance. That is, this OD is so much. So let me join all these by straight lines, and this also a full line. This is going to be a dotted line, and this again a dotted line here, friends. This is the center of the base, say O1. Friends, here you can observe here in all the projections of these solids and also the planes, the first and the second figure in the front view, they will be exactly identical, whether it is a prism or a pyramid or a plane or a lamina. Similarly, friends, in these two figures will be exactly identical. That you should remember. So, 1, 2, they will be identical. 3 and 4 will be exactly identical in all respects. Now, friends, let me project all these points from here and obtain what is called the final front view. Let me start with A. Draw a vertical line from a horizontal line from this A dash. They meet here. I will call this point as A dash. Similarly, B, A and B fall on the same. So this is point B dash. Next comes C and E on this. So I'll write a horizontal line through this and mark C and E. This is A, B, and this is C, this is D, this is E. So friends, I should locate C and E. So C is here, vertical from C, horizontal from C dash. You get the point C dash here. Likewise, vertical from E, horizontal from E dash. The point where those two intersect is going to be point E dash. Finally, D is at the topmost end. So that will lie on this line. So this is going to be the point D dash. Friends, we have got all this, and the observer is looking from this end, and since it is diverging, all these slant edges are diverging, and we will be able to see the complete base A, B, C, D, E. So this is point A dash. So I am going to join A to B, that is A dash, B dash, B dash, C dash, C dash, D dash, D to E, E to A. And friends, O is a vertex. So it's O dash. Try horizontal from O dash, vertical from this O, they meet at this point. So you got A dash, this point is O dash, and this is B dash. Now friends, the vertex is to be joined to all the corners. So I'm going to join O dash to C dash, O dash to D dash, O dash to E dash. And friends, somewhere here, you get what is called O1 dash, the center of this. Now friends, this will give you the final front view of the pyramid, and this is the top view of the pyramid. Now after completing the problem, you as students should verify whether the views you have drawn, that is all these 6 figures, are right or wrong. How to verify it? Friends, this pyramid has to rest on one of its triangular faces. Which is the triangular face? O dash, A dash, B dash. That is on HP. O dash, A dash, B dash is on HP. The triangular face is on HP. And friends, what else is given? The shorter edge of that face is ABO. ABO. Shorter edge is AB. That shorter edge is parallel to VP, and it is at a distance of 10 millimeter. And hence, friends, this solution, whatever I have explained, it satisfies all the requirements that are put in the question, and hence the solution is totally correct. Friends, I hope the presentation was interesting. Please go through the complete video, and if you like this video, don't forget to share the information about this video and my YouTube channel, namely Engineering Drawing and Machine Design by Dr. M.H. Annaiah. Thank you for watching my YouTube video.